Hi there, this is Dr. C. Sonia, Assistant Professor in Chemistry, SNS College of Technology. In this video, we are going to see about the properties of nanomaterials. So properties of nanomaterials, the optical property, that is the nanoscale effects on light interaction. It tells about the optical properties of nanomaterials. Quantum dots. This exhibits the size-dependent fluorescence, emit different colors based on size due to quantum confinement. Metal nanoparticles like silver, gold show surface plasma resonance, that is SPR, strong absorption, scattering of specific light wavelengths, leading to vibrant colors. Example, ruby red gold colloid. So a nano gold material is of a different color than that of the normal gold element. Nanoscale effects on light interactions. So again, we are seeing the transparency. Some materials become transparent at the nanoscale. Example, nano zinc oxide, and it is used in the sunscreen. Ultraviolet blocking. So nanoparticles like titanium oxide and zinc oxide are effective ultraviolet blockers while remaining transparent to visible light. So these will be used in the sunscreen lotions. So electrical properties, that is nanoscale effects on the electron flow. So enhanced conductivity. The materials like carbon nanotubes and graphene are highly conductive in nature, and semiconductor behaviors like the quantum dots act as semiconductors with size tunable band gaps. And again the electrical, that is nanoscale effects on the electron flow. It gives the ballistic conduction, that is the electrons can travel without scattering in some nanomaterials, that is, for example, in the carbon nanotubes, the electron flows, leading to a very low resistance. So quantum tunneling is one more effect, that is electrical effect. The electrons can tunnel across the thin insulating nanoscale layers. The properties of nanomaterials, that is, we are seeing about the mechanical properties, the nanoscale effects on the strength and the flexibility. So increased strength and hardness. Nanocrystalline materials can be significantly stronger and harder than their bulk forms. Carbon nanotubes, they are extremely high tensile strength, that is, they are stronger than steel and stiffness yet lightweight. So this is the very unique nature of the carbon nanotubes. So nanoscale effects again on the mechanical, that is graphene, that is the strongest material ever tested, but it is yet flexible and transparent. Enhanced toughness and ductility. In some cases, nanoscale structures can improve the toughness. So graphene is a unique material which has the surprising strong qualities in the nanomaterials. Next is the chemical and the catalytic properties. So increased reactivity, that is nanoscale effects on the reactivities. So due to the very high surface area to the volume ratio, more atoms are exposed for reaction. Enhanced catalysis, nanoparticles, that is example platinum, palladium, gold, metal oxides are highly efficient catalysts because of the large surface area providing many active sites. So due to the presence of many active sites, the catalytic activity is very high and it enhances the chemical reaction. Again, the chemical and the catalytic properties, that is, it's used extensively in the industrial chemical processes, automotive catalytic converters, and environmental remediation. So properties of nanomaterials, that is based on the magnetic and the thermal, that is effects on magnetism and heat. So magnetic properties, they show the superparamagnetism, that is small magnetic nanoparticles exhibit magnetic behavior only in the presence of an external magnetic field, useful for the data storage, medical imaging, that is the MRI contrast agents. So again, it's about the magnetic and the thermal effects, that is thermal properties, melting point depression. So nanoparticles generally melt at a lower temperature than the bulk materials. Thermal conductivity, it can be enhanced. Example, carbon nanotubes are reduced depending on the structure and the interfaces. So these are some of the unique properties of the nanomaterials. Thank you.